Most apps these days are given away for free with in app purchases being used as the point of sale. This means it is imperative for you to understand receipt validation to determine real paying customers from actual hackers. Apple gives us two methods to validate our receipts. The easy method is to use remote receipt validation. It requires an internet connection and your own server. It's the preferred method since you can get Apple security with ease of use. The second method is to use local on device receipt validation. On device validation only requires an internet connection to get the receipt. Once you have the receipt, it's up to you to verify it and decrypt the contents. It's much harder than remote validation, and since the user has access to the device, it's easier to hack. That said, on device validation gives you the flexibility to create your own custom solution suited to your security needs. This course is meant to be a demonstration and not a drop in solution. Part of the local receipt validation process is intentionally left up to the developer. That way, there isn't a one size fits all solution for all the hackers out there. Here's how it works. When a user makes a purchase or a buy request, Apple will send a receipt to the device. The receipt is simply a signed binary whose contents are encrypted. It's up to you to verify the binary signature as well as decrypt the contents of the binary. Once you have the receipt contents, you will then do an additional verification to make sure everything is good. What do you use to decrypt the contents? Well, that's up to you. You can use the Common Crypto framework, but that framework can easily be compromised on jailbroken devices. Most people use OpenSSL, but this is a high priority target for hackers. You could also find another decrypting framework, or heck, you can even write your own. Each choice gives you options as well as trade offs. Writing your own validation logic and even calling it from code requires defensive thinking, as hackers may be able to change values in memory. You also need to think about how hackers may be able to bypass validation logic as well. You don't just want to validate in your app delegate and move on. You'll want to validate in several places, creating a non deterministic approach for processing receipts. That way, you'll still be able to validate in cases where a hacker skips a validation check. As you can see, there's a lot to consider, but that's not all. In WWDC 2021, Apple released a curveball with regards to in app purchases. As of iOS 15, Apple will be providing their own receipt verification method. This means you can validate your receipts via Apple's APIs. Apple hasn't detailed how the process works in the background and how they intend to keep it secure. Apple also announced a change in the receipt format, opting to use JWS instead of the receipt format detailed in this course. These announcements effectively deprecates this course. But here's the thing, these updates won't be mainstream for at least a couple of years. For the time being, you'll still need to understand how to validate receipts using Apple's older process for some time. You also may adopt some projects that perform manual receipt validation with no intention of upgrading. That said, if you do plan on incorporating manual validation in a new project, then check out Apple's Session Video Meet Store Kit 2 to get you up to speed with the latest changes. Now to get started with manual receipt validation, and for that, you'll need to include OpenSSL as you'll discover in the next episode.